Good morning, and welcome to breakout session Harnessing the Power of NLP, a Vector Institute Industry Collaborative Project. Vector Institute's project, Recreation of Large-Scale Pre-Trained Language Models, the NLP Project, is an industry-academia collaboration that explores how state-of-the-art natural language processing models could be applied in business and industry settings at scale. In this talk, Sedef will provide an overview of the Vector Institute and Applied AI project. She will be focusing on the NLP project and share how industry participants gained practical knowledge through pre-training large-scale language models, learned theoretical concepts from leading NLP practitioners, and broadened their professional network through collaborations with participating sponsors. She will share some of the technical challenges that we encountered throughout the project and how they overcame them. And finally, she will offer best practices to guide future industry projects. It is my pleasure to introduce Sedef Akinli Kocak, Project Manager at Vector Institute for Artificial Intelligence, engaging Vector sponsors on AI projects. Currently, she leads several multi-industrial participant projects. She holds a PhD degree from the Data Science Lab at Ryerson University. After her academic accomplishments, she worked in the data-intensive R&D project development and academic industry partnerships in the area of AI, ML at SOSIP. She is also an experienced researcher in the area of ICT for sustainability and a part-time data science and analytics lecturer at Ryerson University since 2014. She served as a member of the Compute Ontario Board Advisory Committee and AI Program Development Advisor at the Continuing Education University of Toronto. Over to you, Sedef.
Thanks, Maya. Hello, everyone. It's great to be here with you today, and thank you all for joining my session. I'm going to talk about one of Vector Institute's collaborative projects, natural language processing. So let's kick off this by looking at the TripAdvisor of this talk. First and foremost, I'm going to introduce myself, and then I will take you to the Vector Institute and talk a little bit of what the Institute does for those who don't know. Then I will introduce my team, Industrial Innovation Team at Vector, and show some of our applied AI collaborative projects. Then I will visit recent advancement in NLP, Vector's NLP project, and its focus areas. Finally, I will review some of the project's technical limitations, best practices, and leave you with few key takeaways. A little bit about myself. As Maya introduced, I'm the project manager at Vector Institute, where I provide AI project development and management to support collaborations between our industry sponsors, as well as our sponsors and our researchers in building and applying innovative AI technologies to address challenges. I'm holding a PhD from Data Science at Ryerson, where I was focusing on modeling software-intensive systems for sustainability. Prior to joining Vector, I spent my career in building and managing data-intensive R&D projects. I'm also a researcher in the area of software sustainability design. I am the co-founder of Karlskrona Alliance on Sustainability Design in Software Systems. And I've been teaching data science and analytics since 2014. Let me talk a little bit of the Vector Institute. The Institute is a non-for-profit research institute with its mission to lead Ontario's effort to build and sustain AI-based innovation, growth, and productivity in Canada by focusing on the transformative potential of machine learning, especially deep learning. We work together with our AI partners in other parts of Canada, with Canadian industry and public institutions to ensure that they have people, they have skills and resources to best in class at the use of AI. Vector was founded in 2017 by visionary academics from University of Toronto and entrepreneurs who have faced challenges in creating commercial AI technologies. You may recognize from this picture founders Geoffrey Hinton. He is an emeritus distinguished professor at University of Toronto, who is the Vector's chief scientist advisor. And you can also recognize Sanya. She's a professor at University of Toronto and Canada CFAR AI chairs. She's also a director of NVIDIA Lab at Toronto. Raquel Urtasun, she's a professor at U of T and Canada CFAR Machine Learning and Computer Vision chair. She is also head of the Uber ATG Toronto And you can also recognize Tomi Protinian, co-founder of Layer 6 and Chief AI Officer TD Bank, and Ed Clark, of course, the former president and Chief Executive Officer of TD Bank. So let me give you some numbers that might help you to understand Vector AI community. We have over 500 researchers, including faculty members, faculty affiliates, postgraduate affiliates, graduate researchers, and postdoctoral fellows. So far, over 900 participants joined Vector's Institute programs and developed their proficiency required to execute AI projects. And more than 1,000 master students enrolled in a combination of Vector recognized programs and individual AI study paths across Canada. So Vector's industry innovation team leads industry collaborations for driving commercial impact of AI. Our industry innovation projects bring industry and researchers together to apply state-of-the-art solutions to specific industry-related problems. Program participants benefit from collaboration with peers without sacrificing key business information or competitive advantages, and they're able to conduct project experimentation on computing infrastructures that may otherwise be impractical or prohibitively expensive to access for them. Here are a few examples of Vector industry innovation projects. Financial industry project, where we work with Vector researchers and companies to develop governance framework for the responsible adoption of AI, with the emphasis on such as fairness, interpretability, and risk management. In the NLP project, I will dive into in my next few slides, our aim is to retrain transformer-based large-scale deep learning language models to reduce the cost of training while increasing the accessibility and benefit for businesses and researchers. So we have other projects, for example, health project or dataset shift project and model-based reinforcement project. In this model-based reinforcement learning, where we are exploring ways that reinforcement learning can help participants to meet targets for carbon footprint reduction and energy efficiency. So let's have a quick look at recent advancement in the language models. I'm sure most of you are familiar of these figures: increasing model performance and parameters, increasing required computation, and the NLP task benchmarking breakthroughs. For example, the one on your right bottom side, question and answering squad benchmarking. As you can see in this leaderboard, the progress is quite astonishing. So since we started the NLP project last year until now, there have been significant improvement in benchmarks. What about model parameters? We can see that the number of parameters grow at exponential rate. As you can see in the graph on the left side, all the models which are in the curve side of this graph are transformer-based architectures. Transformers have few computational advantages over traditional sequence models or other autoregressive models. Why we all love transformers? Because it's, first of all, it's a computationally efficient. And second benefit is that it has increasing representation capacity compared to traditional RNNs. Now we know that why transformers like models better suit in modern GPUs or TPUs. As you can imagine, and perhaps experience already, that developing and employing NLP models in industry has become progressively more challenging as model complexity increases, dataset grow in size, and computational requirements rise. These hurdles limit the accessibility many organizations have to NLP capabilities, putting the significant benefit advances NLP can provide out of reach. Let me tell you a story behind the Vector's NLP project. A year and a half ago, some of our researchers noticed a trend in NLP benchmark dataset and getting non-trivial progress, and wonder if that could be an ImageNet moment for the NLP field, and would like to investigate further. A lot of these models made a big progress, but some of weren't able at that time, and some of them are still not available even now. And it's also become immediately clear to our researchers and to us that those high-performance models required a lot of compute power that is out of reach for most of research lab companies. only way to move forward in the research and practice in this NLP breakthrough is to collaborate. And Vector take the lead with its researchers, students, and industry sponsors to join force, move forward together to understand the latest progress in the NLP models so no one gets behind. The NLP project addresses computation, dataset, and complexity challenges by familiarizing industry participants with advanced NLP techniques and the workflow for developing new methods that could achieve high performance while using relatively slow datasets and widely accessible computing resources. So let's dive right into the NLP project now. As I said, the project started 1.5 years ago. It was spring 2019. Around 60 participants involved, including vector researchers and staff with expertise in machine learning and NLP, along with industry technical professionals from 16 vector sponsor companies. The participants established 11 working groups, each of which developed and performed experiments relevant to existing industry needs. The project was conducted in 3 phases over 12 months. During the project, Vector Institute provided participants shared computing cluster for development and deployment of NLP models. For the model experiments were organized in 3 areas. First area is domain-specific training, where working groups explored language models applicable to health, finance, and legal field for effective domain-specific training and fine-tuning. Second area is pre-training large models, where working groups train large transformer-based models from the ground up, and they investigated of multi-node BERT large pre-training. Third area is summarization, question answering, and machine translation, in which working groups investigated NLP tasks, including health and finance specific text summarization, machine translation, and health-specific question answering system in response to COVID-19. The project is now completed, and we have organized internal NLP symposium to showcase the outcome of the project. We know that the domain-specific pre-training can provide additional gains over domain-agnostic language models if text data is different from the standard text corpus used to train BERT and other language models. So let's review the health domain-specific area. First experiment, excuse me. First experiment was focused on the replication of some of the finding of the BioBERT study and fine-tune on NLP tasks such as name entity recognition, relational extraction, and question and answering. The second study was on extension of first experiments, aims to answer whether domain-specific BERT, in this case BioBERT health domain, improves performance compared to BERT, which has been trained on domain-agnostic corpora. The group also experimented whether to obtain comparable results from domain-specific BERT model pre-trained on small-size dataset. Our results indicate that the pre-training on biomedical domain corpus improves performance on the downstream Q&A task. However, the improvement is not so large as to be entirely convincing, and carefully fine-tuned BERT models can perform comparably to BioBERT. Now moving on to finance domain. We all know that there are not much of an evidence about performance of the transformer-based models in the finance domain. So the goal of this work was to fill this gap by effectively fine-tuning BERT model on finance-specific data so the NLP researchers in the finance domain could potentially benefit from it. In this work stream, the group provided a semi-automated approach and extract stories explaining financial topics and create a financial data set. And then they performed domain-specific pre-training of using the data set. As a downstream task, the group experimented sentiment analysis. Fine-tuning on downstream task with the pre-trained BERT on finance dataset improved downstream task result on few financial related datasets. One of the value got out of this work is that the developed approach has been used in our sponsors' businesses for document analysis and for automatic customer service. And the code and data corpus and downstream task will be available soon, so stay tuned on that one. Now moving on to the legal domain. The experiment was to investigate various approaches to customize a transformer-based model to legal domain and to compare performance in terms of downstream task and time and memory considerations. So that being said, the group looked at different tokenizations and initial weight changes and found out that there are benefits in domain-specific language model customization. The work is coming out soon at the IEEE Application and Artificial Intelligence in the Legal Industry workshop. As I went over the challenges previously, pre-training of language model is a heavy computational lift. So one group focused on providing algorithmic and system optimization solutions to address these limitations. The group trained BERT large on combined Wikipedia and book corpus dataset. Then they performed some optimizations on BERT large pre-training to improve the single device throughput and fine-tune the training workload with respect to the distributed system topology. Such optimization techniques are used data sharding, automated mixed precision, kernel fusion, data parallelism, and gradient accumulation. This work really demonstrates the ability to perform pre-training on BERT within a reasonable time budget in an academic setting and with a much less expensive and more generic hardware resources requirement than typically assumed required in the industrial setting. The group used around 256 GPUs and training completed around 12 days, which is a reasonable time frame in an academic setting. Technical details of this work can be found in this paper on arXiv. It's been released a month ago, in August, 2 months ago. Now let's have a quick look at the focus area number 3, where the working groups develop frameworks for text summarization in finance and medical domains and machine translation and medical question answering system for COVID-19. One group generated a dataset addressing a challenge on finding a domain-specific dataset in health and finance, and the dataset and technical details of automated technique will be available soon. Another interesting group work came right after the pandemic started. The participants quickly realized that the medical experts need tools and techniques that can be used to quickly and accurately receive answers to their scientific questions related to coronavirus. We took this opportunity and created a question answering pipeline in response to COVID-19 Open Research Dataset Challenge to help medical researchers and experts. In my next slide, you will see developed techniques and some of their details. Most of you may be familiar with the COVID-19 Dataset Challenge. In response to COVID-19 pandemic, the White House and the coalition of leading research groups have prepared COVID-19 Open Research Dataset, which is called COVID-19. This is a resource of over 200,000 scholarly articles about COVID-19, SARS, CoV-2, and related coronaviruses. Then the Kaggle released a challenge over COVID-19 dataset. So we took this opportunity and the working groups developed few different question and answering systems based on combination of BERT and other techniques. As you can see in this slide, these are developed systems. You can find the details of these systems in the Kaggle website. One of the systems was presented at the EMNLP 2020 Scholarly Document Processing session in this morning, and another was presented at the ML for Global Health session at ICML 2020. Although we might say that best practices are still emerging in the AI-related projects, but let's take a quick look of our limitations and best practices here that might help you and your organization to consider them when building your AI models and developing your project. Some technical challenges that we encountered are typical, no surprise here. For example, size and appropriateness of available data set at lack of data set in some of the domains, for example, finance and legal domain, were the main limitations for this project. Having said that, different techniques such as embeddings and projection size were used. Some working groups also created their own data set, as I mentioned in my previous slides. And sensitivity and hyperparameters of such large models would be affect the reproducibility of a model. So to improve performance, the working groups have tuned different hyperparameters such as batch size, step size, learning rates, and scheduling and iterations. As I mentioned earlier, one of the main challenge working with these kind of huge model is computational resources. The participants were given access to the cluster computing, and some groups were demonstrated optimization techniques to overcome this challenge. This collaboration and the result of its experiments provided to be unique opportunity for our industry and researcher participants, but it's also presenting some organizational challenges. For example, self-organizing group development and work distribution was challenged at the beginning because the participants were new to each other and coming from different organizational cultures. This challenge was overcome by group members setting on some common goals and committing a team effort. Another one was the time commitment. The working groups organized themselves in a flexible and adaptable way to cope with this time commitment challenge. Another one is participant turnover and knowledge localization. Due to the duration of the project, we saw that there are high fluctuation of changeover or turnover of the participants. To mitigate the negative impact of turnover, we built a robust project onboarding content and best practices, along with adequate documentation, and we maintain those documentation to ensure that knowledge would not be localized. So the real stake here is that the collaborators feel that they are part of this big project, although it's voluntarily. All the participants balance each other, and the total success was greater than the sum of its parts. Let's take a look at some of the best practices. It's really important to keep the motivation high in these multidisciplinary and multi-stakeholder projects. So we identify quick wins to generate easy success and momentum. And another one is to monitor progress and impact regularly. The roles and responsibilities were defined, and the operational plan for the collaboration is established at the beginning. And last but not least, planning and effective knowledge transfer for participants. So we introduced topic-related seminars where participants learn recent advances in the area, and setting out experiential learning where participants perform hands-on tasks together. And this fostered working group performance and enhanced productivity. So now I would like to leave you with a few takeaways. Let's reiterate that working with the large models are challenging. There are successful developed algorithmic and system optimization techniques that can be used to partially overcome some of these challenges. Prior domain knowledge improves the performance of some of the NLP tasks in the domains. Although it requires further investigation, using small-sized dataset can be especially useful when the model needs to retrain due to, for example, dataset shift or a wide variety of data domains, confidential data not publicly available to the trained model, or small size of the domain-specific data available, and a lack of computing resources. As I mentioned earlier, the availability of data and computational resources, model sensitivity, and hyperparameterization, as well as the black box nature of these models, reveals several potential areas for future work. Increasing the collaborative partnership and interdisciplinary approach in the way exemplified by this project, it will continue to ensure that the opportunities are made available widely. So last but not least, I would like to share with you some of the success stories. Insights gained in the NLP project have informed some of our partners' programs and products developed in some of our participating organizations. For example, two of our sponsor organizations who participated in the project have already been benefiting using transformer-based models. Now, I would like to thank you to all of my colleagues and all the NLP project participants, especially our faculty members, Jimmy Ba, Gennady Pekimenko, and Frank Rudzik, and all our participants. Now if you'd like to learn more about, please visit our website at Vector Research and Programs, and I'm happy to take your question now.
Thanks so much, Sedef, for your presentation. The first question we have for you is, models in NLP will only get larger from now on. How can small research labs and companies conduct research on those gigantic language models?
Yes, this is a great question. Just to be clear that we are still far from creating AI models that match the complexity of our human brains. So our brain is like around 100 billion neurons. That neurons are roughly equivalent to the parameters in artificial neural networks, and more than 100 trillion synapses. So size does matter, but it's not everything. So you still need data, but significantly less effort. There are much simpler solutions architected with fewer custom modules. Big models are not silver bullets. Do not ignore the other hammers in your AI toolbox. As a practitioner, focus on value creation, not the choice of tools. Even more than ever, do not skim the evaluation, and it's important to evaluate performance on the tail because the professional specializes. And we also think about bigger picture. With creating bigger networks and throwing more compute and more data at the problem causes also problems that are often overlooked. Among those problems, we could be like cost and carbon footprint of developing such models. I think that these type of models will be quite important, but that no matter how much we scale them, we are still missing components. So I think in terms of getting final product that has best performance, I think small research labs need to wait maybe the big companies to release their models, or as I explained earlier, there are system techniques or other techniques that needs to be considered.
Thank you. What are some of the biggest obstacles or challenges to AI in general, NLP in particular, having a bigger impact in industry?
This is a great question. So there are plenty of challenges, and plenty of state-of-the-art models help us to solve like more difficult problems and more exciting problems in the NLP domain. And then there are more needs to be done there. We have plenty of tools to solve problems even today. I think in the industry's one of the biggest challenge is to identify exciting, relevant, and very impactful use cases. Not only technically interesting, but also impactful in the business perspective. So we have to think about, like, can it drive a significant impact on companies' business performance? So we need to think about those. The problems are harder to come by in general because you need to creative product developers, the creative teams who understand the business need, understand customers and opportunities. So another obstacles or challenge would be a shortage of talent. So this is a real and pressing problem for most businesses wanting to adopt AI. When it comes to the capitalization on the like enormous potential for growth offered by AI, and the bottleneck exists due to the shortage of data and technology professionals with the experience and training need to implement the required infrastructure, and also the organizational change. So to fill this gap, Vector's program, led by top Vector Institute researchers and professional staff, build fundamental and advanced skilled in technical teams and deliver key business insights to execute and non-technical professionals. As a complete suite, we have programs help organizations in all sectors at the levels of adoption, develop the proficiency required to execute a project as a part of larger AI strategies.
That's actually a great segue into the next question. This question is from David. How do you balance keeping researchers interested, engaged in projects with company stakeholders who have to think in terms of practicality and application?
This is a great question. So, so we engage like daily or weekly or like with our researchers as well as our companies, and then to find the common ground of their interest. So this is important. And then we also look at what are the challenges in the industries and how those challenges could be solved by our researchers or their research interests, so then they can collaborate. So this is important. And then also another important part is to amplify or to focus on the impact. Like the researchers can develop a great solutions and how these solutions can be impact in the business applications. So I think this is the important to connect those dots and then connect researchers as well as the industry practitioners regularly, so then they can understand each other, they can connect each other, they can talk to each other, so then they can create solutions for both valuable to the industry as well as the researchers.
Two more questions, Sedef. Our next question is from Ricardo. Do you think dedicated hardware, example FPGA, can reduce the cost of training NLP models?
This is a great question, but I'm not technical expert on the FPGAs. I know a little bit of an FPGA cards. So I think there are some research on the FPGAs, and then using the FPGAs, training the models. I think it's a great potential, but we haven't used those kind of technologies in our site.
Thank you. Our next question is from Ting. Are there use cases at Vector Institute leveraging GPT-2 or GPT-3 and comparisons with other transformer-based modeling?
Yes, this is a great question. So some of our researchers did look at the GPT-2 in this project. So they looked at the GPT-2. It was available at the time. We haven't looked at the GPT-3 yet. So we will have a next cohort of NLP project coming next year. So maybe one of the focus areas will be GPT models.
And one more question, Sedef. This is from Tyrone. How do researchers currently get access to HPC resources to run their NLP models, and who provides these today?
Okay, this is a great question. Thank you, Tyrone. So in our researchers at Vector Institute, we have our own computing cluster. So we have 2 and 3 big clusters. Those clusters include number of GPUs. So our researchers and students have an access to those clusters. They can run their models or run their researchers on using those computing resources. So if our sponsors, they don't have an access to our cluster, but some of our projects, for example, the NLP project that requires a computing resources. So we give access to our sponsors, limited access to our sponsors who are involved in this kind of project, so they can run their models into our clusters, basically. Oh, there are one more thing. So there are like initiatives or consortiums, for example, smart computing platform at U of T and Western. So they are providing this kind of high performance computers. So if you're not in the research lab, or if you would like to, if you are in small companies, so there are those kind of initiatives. I know NGen, Sengen, and SOSIP, and there are a few other organizations who has those kind of capacity, And then you have to take a look at their website and then their requirements. So they do provide this kind of services, like high performance computing services. So then they are available for fee. They require fee, but there are some available resources out there.
Great, that concludes our Q&A for today. Sedef, thank you so much for your presentation, and thank you to everyone who attended our breakout session today on behalf of the Vector Institute. We hope you find time to visit us at our booth space today. I've included the link in the chat box, and if you do have any follow-up questions for Sedef, please do feel free to reach out to me. My email is in the chat box as well. Have a great day, everyone.
Bye, everyone. Thank you.